Hello everyone and welcome to the first video of Rocket Tutorials. In light of the current situation, I am aware that every one of us is affected by the coronavirus in some way or another. And I hope that everyone's doing well and staying safe. I'm sure that most of us are aware of the dangers and consequences of going out. And even without having protective equipment, some of us are still passionate and determined, well, if not obliged to get to work. Seeing our frontline workers in that situation is hard for us, and some of us have taken the initiative to help by giving cash donations or even to the point of making the equipment themselves by means of 3D printing. I won't go over too much of the details when it comes to 3D printing. There are other videos for that. What we are going to run through is a quick start guide for someone who has no engineering background or technical knowledge, especially with 3D printing. Though 3D printing is already well on its way, transforming from a niche machine to a staple, this was further sped up by the lack of PPEs. Owners are doubling up on their printers, and some people are now trying it out for the very first time. As someone being exposed to 3D printing from as early as 2013, I thought of the idea to add to my contribution by teaching about the technology through these tutorial videos. So without further ado, let's get started. The simplest way to categorize the requirements is to cluster them into three things. This would be the design, software, and machine all overlapping with each other. That would be because to 3D print something, you would need a certain design, a certain software, and a certain machine. Now all of these may vary as we all have certain preferences. A certain software, a certain machine. Obviously, with design, each one of us usually wants to print our own thing. Moving on to software, each one of us may prefer a certain UI. And lastly, for our machines. Each one has its own unique machine specification. Now let's bring up the first topic, the design. There are many ways to have a design. We can create one, but that's for another video. The simplest way is to get one online. Of course, with anything online, anyone could get it, either with a fee or for free. Arguably, one of the most prominent sites to get these designs is in thingiverse.com. So here's an example, something that's useful for these days. Click download. You can support the creator by giving tips, but then again, that's totally up to you. Now that that's done, we unzip the file, and here's what we need, the STL file. Given the STL file, we now have the design we need to 3D print the item. I'll talk about the STL files and other 3D file formats in another video. Next in the list is the program, or what we in the printing world call the slicer. Basically, a slicer is just a CAM software targeted for 3D printers. Simply put, a program to interpret the design into the language of the machine. The idea is to slice the object into layers, thus the name slicer. Then what it does is it maps out movements per layer from the first to the last. One example that I'll be using is the Cura 4.5 slicer. As I'm going to demonstrate, this software will slice the object per layer, then map out the movement. The slicer will also be where you input all your preferred settings. I'd recommend sticking to what your slicer recommends before tweaking each and every single settings available for tinkering. But of course, as you progress, you would learn to tweak a bit of this and that. With this, the next thing to do is slice and export the G-code. The last of today's list is the machine. There are loads and loads of machines out in the market. The price would range around $100 to hundreds of thousands of dollars. But for beginners, any reliable desktop 3D printer would do just fine. Printers these days come in all sorts of shapes and sizes, with different printing techniques and capabilities. I mean, there's a lot of cheap printers from China that could rival a forefront European breadwinner, DIY, and plug and play. I mean, there's just lots of variables. So in the end, what printer should you buy? That would fall on what you choose to print, what for, and your expectations for it. As mentioned earlier, these machines come with different specs, and one of the most common things to consider is build volume. You can't print for something as big as your head, for a printer that can only print as big as your hand. This is true for all types of printers. Not unless you print it by parts, then assemble them afterwards. Next is the reason for printing. What the general public is exposed to right now is what you call FDM printing. That's where you see people racking up all those expensive spools for 3D printing materials. Most probably, it's those printers that you see all over the internet. Then there's this must-have for artists, SLA printing, where no evident layer indications are found and is the best in revealing high standards of details. Or you could consider printers that are aligned for 3D printing food, metals, or organs. Lastly, expectations. For good or for worse, even a seasoned 3D printer end user occasionally encounters some failed prints. It does not mean that if you bought the most expensive printer, that you'd get the perfect prints every time. That would only be overcome by getting to know your printer and your printing environment. Know what's can and can't with your current setup. There are some who intently choose DIY printers for modding or adding to the capability of the printer. There are others who just tweak the settings in their slicer. And for some, it is as basic as switching the brand of filament or resin. A lot in 3D printing is found only by your imagination. As mentioned, it is what you want to print and how you want to print it that matters. As years pass, it's just getting more and more exciting. I hope that this video was able to further inspire you to be part of the 3D printing community. See you on the next video and happy printing!